This ME lecture concerns the naming of alcohols, ethers, and epoxides. So first of all, let's figure out what an alcohol and an ether actually are. Alcohols are characterized by carbon chains with an OH attached, and it's the H here that's important for the alcohol. An ether is characterized by an oxygen with two carbons directly connected to it. So the H is actually is actually replaced with a C when we're talking about an ether. So when we're naming alcohols, the alcohols end in the suffix OL, and you put the alcohol position in the front of the name. So if you had something like this, it'd be 1-pentanol. It's a 5-carbon chain, and the 1 here is because the OH is on the 1 carbon if we were numbering it. This one is 2-methyl-3-pentanol. So we've got 1, 2, 3. So it's 3-pentanol. That tells us the OH is on the 3rd carbon, and 2-methyl because the methyl group is on the 2nd carbon. This one here is 8,8-dibromo-2-octanol. This reflects the notion that the name of an alcohol is going to be determined by the positioning of the alcohol on the chain and not by the lowest possible numbering set. So we want the lowest possible number for the alcohol on the chain. So this would be numbered 1, 2, 3, 4, 5, 6, 7, 8, and not the other way. So this would give us OH as being on number 2 instead of OH as being on number 7. It seems to go against the rules because we've always said in the past that we want the lowest possible numbers for the substituents on the chain, but when we get to alcohols and to alkenes, as you'll see later, what happens is that the priority is set by the positioning of the OH grouping. Likewise for this one will be 3-chloro-1-propanol and not 1-chloro-3-propanol. So it's not like this can be named in both directions. It can only be named in the way that puts the OH in the lowest possible numbering position. When dealing with cyclic alcohols, we assume that the OH is in the 1 position on the ring, so this would just be called cyclohexanol. And likewise, this would be 2-methyl-cycloheptanol, the methyl group being in 2 position, the OH assumed to have been in the 1 position. So we don't say 2-methyl-1-cycloheptanol, that would actually be redundant. So we just make it 2-methyl-cycloheptanol with the assumption the OH is in the 1 position on the ring. When we're naming ethers, we can name them in 2 ways. We've got the UPAC naming, and this would be ethoxyethane, where this group here, the O, is called ethoxy, and then this would be ethane right here. We're going to preferentially name these according to the old method, because most people tend to name ethers using the older method. And using the older method, what happens is we look at the groups that are attached to the central oxygen, and then we name the ether accordingly. So the fact that we have 2 C's connected to the O is what makes this ether. So that's where the word ether is coming from here. The diethyl part is coming from the ethyl group here and the ethyl group here. So this would be diethyl ether. We don't have to worry about the alphabetization when we're naming ethers in this old method. This one is methyl ethyl ether, and you could also name it ethyl methyl ether if you wanted. This one would be ethyl butyl ether. There's your ethyl group and there's your butyl group, and this one would be propyl sec butyl ether. Note the dash before the sec, and the reason we have a dash before the sec is because we have a dash after the sec, and that's one of the patterns we see with naming, is that if you've got a dash after something, you're going to have a dash before it as well. So this would be propyl sec butyl ether, not just propyl sec without the dash here. The other way of naming this, sec butyl propyl ether, would be fine as well. Here's your sec butyl group, and there's your propyl group here. The epoxides are a bit more complicated to name, and the naming is brought about by the from the alkene from which the epoxide is actually produced. And the reaction that we're using here to name this is this one here, where we take an alkene and we treat it with metachloroperbenzoic acid. What happens here is that when you take an alkene and you treat it with this reagent, it will turn into an epoxide. The other thing is that it's going to be a stereospecific reaction, which means that if you start with a trans alkene, you'll end up with a trans epoxide. If you start off with a cis alkene, you'll end up with a cis epoxide. I want you to note how you can tell if an alkene is cis or trans. A trans alkene is always going to look like a zigzag, while a cis alkene is always going to look like a cup around the double bond. Alright, so what I'm going to do is I'm going to go back here and take a look at some examples, and then I'll do some examples as well for you so that you can make sure you understand the concept of naming epoxides. Alright, so this compound here is this is a compound we're trying to name, and as you can see, it's a cis epoxide. And the way that it's named is that we take this and we take the oxygen off and we turn it back into the double bond compound from which it was made. And since this is cis here, this must have been a cis double bond, so this would be cis to butene. The way that alkenes are named is that we number the chain. It'd be 1, 2, 3, 4, and the alkene, like the alcohol, gets the lowest possible number that we can give it in the chain. So this makes it 2-butene, and since this is cis, it's going to be cis 2-butene. So we go back up here to the epoxide, and the oxygen here is the oxide part. So this would be cis 2-butene because it comes from this oxide. This one, as you can see, is trans, and it came from trans 2-butene, and the name of this one would be trans 2-butene oxide. Alright, so a couple more examples. As you can see, this one is trans, and it came from this alkene. Now, the way that we figure out the alkene that it comes from, all we do is we just take the oxygen off here and we replace that with a double bond. We obey the stereochemistry that we see here and put the same stereochemistry on the double bond as well. So since this is trans, we make it a trans double bond like this. Then we can name the alkene and we number it from this end because that'll give us the lowest numbering set for the chlorine. So it'll be 1, 2, 3, 4. So that's going to be 2-chloro and then 4-octene, and it's trans because it's a trans double bond. So it's trans 2-chloro 4-octene. This one is going to be, what we're going to do is we're going to take the oxygen off here, and since this is cis, we'll make this a cis double bond like we have here. And then we can number this, and we have to number it from the end if it's going to give us the lowest possible number for the alkene. So we have to number it from this end. It'd be 1, 2, 3, 4, 5, 6. So this will be 5-chloro-2-hexene, and since it's a cis double bond, we're going to make it cis 5-chloro-2-hexene. So going back to the name of the epoxide, it's going to be cis 5-chloro-2-hexene oxide. Here are some examples of naming epoxides. So the first thing we do is we look at the epoxide and we see that it's cis. And now what I'm going to do is I'm going to write down the alkene from which this would have been prepared. And that really is just a matter of copying it and then replacing the O with a double bond, and then making sure that the stereochemistry of the alkene matches the stereochemistry of the epoxide. So this is cis because they're both coming out, which means the double bond here is going to be cis as well. So to name the alkene first, and then I can name the epoxide, I'm going to have to number this so that the alkene gets the lowest possible number in the chain. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this is regardless of the fact that this would not possibly give us the lowest numbering set for the substituents. What's important is that the alkene gets the lowest possible number it can in the chain. So the name of the alkene, since it's cis, it's going to be cis, and it's going to be 7,7-dimethyl. And then I put the position of the double bond in there, so that's going to be 2 non-ene. So that's going to be the name of the alkene, cis 7,7-dimethyl 2 non-ene. And then to get the name of the epoxide, I simply add the word oxide, and I put a space in here as well. So space oxide, cis 7,7-dimethyl 2 non-ene space oxide would be the name of this one. Alright, looking at the next one. Again, I will go ahead and write out the alkene from which this would be prepared. So we've got that there, and the double bond would go where the O goes. And then we've got our substituent groups here and here. Alright, so that's the alkene, and again we're going to do the same thing as we did over here, but we're going to number this so that we get the lowest possible number we can on the alkene. So it'll be 1, 2, that'll be 3, 4, 5, 6, 7, 8. So if I numbered it from the other direction, it would have been 1, 2, 3, 4, 5, so it would have been 5 on the alkene, and that's going to be bigger than 3, so we'll go with this direction for the numbering. The name then becomes, well, since it's we look at the stereochemistry, we see that this is going out and this is going in, so that's trans, so that double bond there is trans as well. So it's going to be trans, and then the substituents, and it looks like it's going to be 1,6 dichloro, 1 nitro, and it's going to be a 3 octene. Alright, so that's the name of the alkene, and then to get the name of the epoxide I simply add the word oxide after a space, just like I did before. Alright, so that's the total name for this one, trans 1,6-dichloro, 1 nitro, 3 octene oxide. Alright, let's look at a situation now where the epoxide is on the end of a chain. So again, I will write out the alkene. Now I want you to notice here that since we have 2 hydrogens on the end of this alkene, there is no cis or trans associated with that. Now the reasoning for this is related to what we saw with the E and Z naming. When we saw 2 of the same group attached to a carbon in an alkene, we know that there was no E or Z, it was neither. And that's the same with cis or trans. When you've got 2 hydrogens here, there's no cis or trans to worry about, because we can't find a priority between two different hydrogen between the same two hydrogen atoms. So when we name this, we simply name it as, this would be, well, with the numbering, again we have to number it so that the alkene gets the lowest possible number, and it's going to be a heptene, so it's going to be 4 methyl 1 heptene. There's no cis or trans or anything out the front, it's just blank because there is no cis or trans associated with this, so it's 4-methyl 1-heptene, and then to get the name of the epoxide it's just going to be 4-methyl 1-heptene and then space oxide. Okay, looking at the last one. This one's a tad tricky because we have to be sure of what the main chain is and what the substituent group is. The substituent group in this case is here. It's called cyclobutyl. And the reason that we have to go with this is we'll go ahead and we'll show the alkene here and it'll become a bit clearer. So it's a cis epoxide, so it's going to be a cis alkene here as well. And we have to figure this out as being the base chain because the double bond has to be inside the base chain. So this is going to be the base chain and this is going to be a substituent group. The numbering goes like this: 1, 2, 3, 4, 5. It doesn't start here because this is actually part of the substituent group, and we never include substituent groups as part of the main chain. So when I'm doing the substituents or covering the substituents, this is going to be cyclobutyl, which looks like this. And then it's got a join, and that join is this bond right here. So the cyclobutyl is a group. That's not to be confused with cyclobutane, which is a compound which has 8 hydrogens, unlike the previous one, the cyclobutyl, which has 7. So any time that we want to figure out the name of a group, all we have to do is find the name of the compound it would make, then take off the ane and add YL. So YL will be the suffix that you'll see for most substituent groups. So it's not cyclobutane, it's cyclobutyl. So the name of this then would be, based on the alkene, it would be 1-cyclobutyl, and it's going to be 1-pentene, and it's going to be cis because this is a cis double bond, so I'll put a cis out the front. And the name of the epoxide would be cis 1-cyclobutyl 1-pentene, then a space, and then the word oxide, and that would be the name of our epoxide here.